Okay, example 3. Find which IQ scores separate the bottom 80% from the top 20%. And if you recall this is from example 1, the mean's 100, standard deviation is 15. So let's draw this out. So we want the top 20%, so somewhere over here where this here is 0.2 and this here is 0.8. So this is separating this. We want to know what is that value right there. Find that value. We've done this before when we looked at just standard normal. It's done exactly the same way. We just have a context now. So I'm going to go to inverse norm. So second vars, number 3. The area, again, when we're using the calculator, is the area to the left of this value here. So I'm going to put 0.8. If you're using the table from the online text, remember it gives us the area to the right of the mean. So we would look that value up, and we'd actually have to convert these to z-scores. I'm not going to do that. We're just going to stick with technology here. 0.8. The mean is 100. Standard deviation is 15. And then press enter. And we get 112.6, which looks about right. If I'd gotten a value like 88, I would know something was a little bit off. I'd gone the wrong direction or something. Example 4. The percent of fat calories that a person in America consumes each day is normally distributed with a mean of about 36 and a standard deviation of 10. Suppose that one individual is randomly chosen, and let's let x equal the percent of fat calories. So part A, find the probability that the percent of fat calories a person consumes is more than 40. Graph the situation, then shade in the area to be determined. And then I always kind of glance at part B, find the maximum number for the lower quarter. So we're looking for Q1 of percent of fat calories. Let's sketch the graph and write the probability statement. Okay. Since we are turning to technology to do more of these, the showing the work part is this right here, is drawing the stuff on the curve. So when you're looking for the area, you're going to go to norm CDF. If you know the area and you're looking for the value, you go to inverse norm. So the lower, going from 40. Upper is infinity. Mean is 36. Standard deviation is 10. And we get about 34%. So 0.34. It says probability, not percent, so I'm trying to answer the question that they gave me. Corresponds to 34%. Sometimes probabilities are given percents. Usually they want this as a ratio or a proportion. And here are the screenshots here. Lower 40, upper 1E99, 36 and 10, and we get there. Again, if you have an older model, you can put it straight in. Lower bound, upper bound, mean, standard deviation. Okay, for part B, now we're trying to find the maximum number for the lower quartile, Q1. So lower quartile, somewhere around in there. There's my Q1. That's what I don't know. I'm trying to find that value there. So that value there is 0.25, the lower quarter of percent fat calories. So what would that value be? We know it's going to be something less than 36. Okay, rather than showing a live shot, I've got the screenshots here. We're going to go into the inverse norm. 0.25 is the area. Mean 36, standard deviation of 10. Click paste, and you get about 29.3. And similar if you have the older model calculator, you get exactly the same result. Slightly different syntax.